Van de Graaff generator. In the year 1931, the scientist R.J. Van de Graaff had constructed a machine with the help of which a potential difference of the order of several million volts, 10 raised to 7 volt, can be produced. This machine is called Van de Graaff generator. Principle. The Van de Graaff generator is based on the following principles. First one, the surface charge density at the pointed end of a conductor is maximum. When the air comes in contact with the pointed end, then the air gets ionized. The positive ions of air are repelled from it and move away from it. This is called electric wind, and this phenomenon is called action of points. So the first principle of Van de Graaff generator is action of point charges. We will discuss that one in our video explanation itself. And the second principle is that the charge given to a hollow spherical conductor is distributed uniformly over its upper surface. So these are the two principles of Van de Graaff generator. Let's see the working of Van de Graaff generator. For studying the working of a Van de Graaff generator, we need to understand the construction first. The construction of a Van de Graaff generator is shown in this figure. It consists of a large spherical shell that is represented as A. It is a hollow spherical shell. And the hollow spherical shell is supported on a 15 centimeter huge insulated stand. So this stand cannot conduct different charges. There are two pulleys, B as well as C, and a belt made of insulated fabric runs over the two pulleys, both B and C. The pulley C is arranged in a way near to an electric motor. A metallic comb D, which is shown here, is connected to high voltage rectifier or to a high tension battery. The comb D is called spraying comb, and the comb E is called collector comb. The comb E is connected with the sphere, that is A. Now the pulley C is connected with an electric motor, and it will help the pulley to rotate. To prevent the leakage, the generator is enclosed in an earth steel tank. Inside the steel tank, air or freon is filled at about 10 to 15 atmospheric pressure. Now let's see the working. As the comb D is connected to positive terminal of a high tension battery, hence at the pointed tip of the comb, the surface charge density is maximum. When the air particles comes in contact with these sharp points, then they get positively charged, repel from these points and move towards the belt. It is called the electric wind. As the comb D sprays positive charge, so the part of belt which is in front of the comb D gets positively charged as shown in figure. During rotation, when this part of the belt comes in front of the belt, that is E, then at the sharp points of comb E, negative charge is induced, and on the outer surface of sphere A, positive charge is induced. See here, since the comb E is getting negative charge because of induction, the sphere, the hollow sphere, the outer surface of the hollow sphere is getting positive charges. The positive induced charges is therefore distributed uniformly over the surface of the sphere A. From this point of view, you can understand the positively charges are distributing uniformly across the outer surface of the hollow sphere, that is A. As the sharp points of the belt, that is E, are at negative potential, so the electric wind is produced which neutralizes the positive charge of that part of the belt which is in front of it. When this part again released to front side of the comb D, it again gets positive charge and again induces positive charge on the outer surface. This process continues and the potential of sphere becomes very high. This is the working of Van de Graaff generator. So we will get high potential because of the use of Van de Graaff generator by the action of point charges. The uses of Van de Graaff generator. The first use of Van de Graaff generator is to produce a very high potential difference. And the second use of Van de Graaff generator is to accelerate positive charged particles like protons, deuterons and alpha particles, etc., and to increase their energy. And the third use is that for inventions in nuclear physics, we will use Van de Graaff generator. And here are the demerits of Van de Graaff generator. The first demerit is, due to its huge size, it is inconvenient in daily applications. And the second use is, since very high potential is produced by it, so it is very dangerous to use the Van de Graaff generator. So very high potential is produced by Van de Graaff generator. So it is very risky when we are using Van de Graaff generator. And the third demerit is that I already told you in uses, to accelerate positive charged particles like protons, neutrons and alpha particles, we can use Van de Graaff generator. So Van de Graaff generator cannot be used to accelerate negatively charged particles such as electron and it cannot accelerate neutral particles also. For construction and maintenance, the Van generator cost is very high. So these all are the limitations of Van de Graaff generator. Now go through the given slides and use them to write the notes by yourself. Thank you, students.